Hello and welcome back to part 2 of section 1.7 of geometry. Let's now complete the example problems together. Example 1. Identify solids. Determine whether each solid is a polyhedron. Then identify the solid. If it is a polyhedron, name the bases, faces, edges, and vertices. So first up, this is all composed of straight lines. Yes, it is a polyhedron, and it is a rectangular prism. Now we can name the bases as, honestly, for rectangular prisms, you could choose any pair of parallel faces. The classic ones here would be the so-called bottom and top right there. So let's call those rectangle MNOP and rectangle RSTQ. Other faces would be the other 4 rectangles. So I could do I'll call it the front-facing one. I see QTOP, and then its parallel partner in crime, as it were, at the back there. Make that a little bit longer. RSNM. And we also have the sort of left-facing side here, RQPM. And then at the back right, STON. And don't forget that these 2 bases are also faces as well, but I won't duplicate my list here. All of the edges there's going to be quite a few of them. All the segments listed here. I think I will go based on the bases as well. We'll do those 4 at the bottom, then 4 at the top. So we have segment MN, segment NO, and then OP and PM. And then on the top face, we'll have segment RS, segment ST, segment TQ, and segment QR. And I'm able to just read that off of the name of the base there. And then we also have to connect up the bases to each other. So I'm going to start on the left-hand side, go top down, RM. Here, I'll just write it here and move it over. So we have RM, SN, TO, and QP. I'll just bring that over. That is not what I meant to do. Is there any way I can grab only the writing? I don't think so. Duplicate. And cut, and it took all the writing with me. Well, you get the idea. We'll clean that up later. Let's go on to shape B. This is not a polyhedron because it's a cylinder. And thankfully, we don't have to list anything for that. Shape C. Yes, this is a polyhedron, and specifically, that would be a triangular pyramid. The triangular pyramid has only a single base. Well, any pyramid has one base. That's triangle, triangle. Good enough. A, B, C. The other faces will be all triangles. Let's go A, D, C. Oops, what happened there? And then let's call the back A, D, B. And then the right side will be B, D, C. Sure. And edges. We have segment A to B, segment B to C, and segment C to A, and then all up to apex D there. So A to D, B to D, and C to D. Okay. Oh, we didn't actually list the vertices, so sorry about that. Just realized that. Vertices. List all the letters. M, N, O, P, Q, R, S, T. Yeah, that's everything. Okay. And down here, vertices, we have A, B, C, and D. Example number 2, find surface area and volume of the square pyramid. Okay, so surface area for the pyramid is composed of 2 parts. We have the area of the base itself plus the area, the lateral surface area, which will be, I think it was something about the perimeter times the slant height. You know what? I have my notes here. Let's just check. Yes, right here. 1/2 perimeter times slant height plus area of the base. Okay, which in this case, the base itself is a square, 6 centimeters on a side. Area of a square is found side length squared, so 6 times 6. The perimeter of the base is being a square. It's going to be 4 sides of 6 centimeters long, so 4 times 6 for the perimeter there. And the slant height is 5. So we get 36 here plus 1/2, 24 times 5. Half of 24 is 12 times 5 is 60. 36 plus 60 for a grand total of 96 centimeters squared. Notice that we only ever multiplied 2 lengths by each other at a time. We get an area unit. And for the volume of a pyramid, double check again. That's got the 1/3 in it. Yes? 1/3 area of the base times the height. One-third, capital B times lowercase h, height of the pyramid. We found the area of the base before. That was 36. No sense recalculating that. The height of the pyramid, the proper height here is 4. And 1/3 of 36 is 12. And 12 times 4 is 48. So 48 centimeters cubed. This is volume. We're now in a 3-dimensional measure, cubic units every time. All right. Example number 3. The diameter of the pool Mr. Sato purchased excuse me, is 8 feet. The height of the pool is 20 inches. Find each measure to the nearest tenth. So we're going to the tenth. Notice this is feet, this is inches. We need our units to match. So I'm going to real quick convert inches to feet. You can convert feet to inches. You'd end up with much larger numbers in your calculations here. Inches over 1. I have inches on top. Put those on the bottom. Convert them into feet. 1 foot is 12 inches. 20 divided by 12. Let's see. Half of 20 is 10. Half of 12 is 6. Half of 6 is 3. Half of 10 is 5. So we have 5/3 of a foot. And of course, the inches reduce as well. All right, 5/3 of a foot. Or 1 2/3. Whatever. I prefer the improper fraction. So, surface area of the pool. The pool itself is clearly a cylinder. Surface area of a cylinder. Let's remind ourselves of that one. Right here. 2 pi r h plus 2 pi r squared. Two pi r h plus 2 pi r squared. So in this case, our radius, if the diameter is 8 feet, that means the radius is half of that, 4 feet. So we have 4 times the height, 5/3, plus 2 times pi times the radius of 4 squared. And this would be 2 times 4 is 8. 8 times 5. 4 times 5 is 20. 8 times 5, 40. Yes, 40/3 pi plus another 4 times 4, 16 times 2, 32 pi. So that's the most precise exact answer, but since we're going to have to put it in the calculator anyways, we want to round our answer to the nearest tenth, so we should get 92.2 feet squared. And how about the volume of water to fill the pool to a depth of 16 inches? So this is a new height h. We're no longer using the 20, so 16 inches. Put that over 1. Convert again. We want inches to feet. 1 foot is 12 inches. Those can be divided by 4, so this is 4/3 of a foot instead of 5. So now let's see, volume for a cylinder. Remind ourselves here. I left my highlight from before. Now I want the volume, so pi r squared h. Pi r squared h. It's actually a little simpler. Volume equals pi r squared h. So pi again. Our radius is still 4 feet. And now the height is 4/3 instead of 5. So that's going to be 16 times 2 is 32. So times 4 is 64. So this is 64/3 pi in exact form, rounded to the nearest 10th place, 67.0. Yeah. Okay, there you have it. That was the last example. So that completes all the example problems for section 1.7. So long, farewell. Enjoy the rest of your day.